If you've ever flown into a community in the Canadian North, a place with no road, no rail, and no runway longer than a football pitch, the aircraft that got you there was almost certainly a de Havilland Twin Otter. 844 were built at a single factory in North Toronto, and they flew into more than 90 countries: the Arctic, the Antarctic, the Himalayas, the Maldives, Papua New Guinea. They survived polar ice, saltwater corrosion, 40 below winters, and 60 years of continuous service in the most punishing environments on Earth. Survived the nationalization of their parent company. Survived being sold to Boeing. Survived having their production line shut down and their tooling destroyed. And then, after 94 years of building aircraft at Downsview, the factory fell silent for the last time. How does a machine that outlasted everything, the cold, the corporations, the politics, end up without a home? What happened inside those hangars? Chapter 1. The Curate's Son and the Crated Moths. The story begins with a man who couldn't stop building aeroplanes, and a country that couldn't survive without them. Geoffrey de Havilland was born on the 27th of July, 1882, in the village of High Wycombe, Buckinghamshire, the son of a Church of England curate who would have been perfectly content to see his boy enter the clergy. Geoffrey had other plans. He borrowed £1,000 from his maternal grandfather, rented a workshop, and built his first aircraft from spruce, wire, and ambition. In 1909, near Seven Barrows in Hampshire, he attempted to fly it. He crashed on the first hop. He rebuilt. He crashed again. He rebuilt again. By the time the Great War ended, de Havilland had designed more than a dozen aircraft types for the Royal Aircraft Factory and its successors, survived the sale of his wartime employer, Airco, to BSA, and in September 1920, with £3,000 of his own money and £10,000 from his patron George Holt Thomas, founded the de Havilland Aircraft Company at Stag Lane Aerodrome in Edgware. His 60th design changed everything. The DH-60 Moth, named for Geoffrey's lifelong passion for entomology, because everything about this man had a slightly eccentric English quality, first flew on the 22nd of February, 1925. It was cheap, light, reliable, and simple enough for a weekend enthusiast to maintain. It ignited the global flying club movement. Within 2 years, de Havilland was shipping moths to buyers in Canada in wooden crates, and the demand was outstripping what a transatlantic crating operation could sustain. On the 5th of March, 1928, the de Havilland Aircraft of Canada Limited was incorporated as a wholly owned British subsidiary. The first general manager was R.A. Bob Loader, dispatched from the parent company's factory at Hatfield, north of London. Loader set up a small office in the Sterling Tower at 372 Bay Street in downtown Toronto, struck a deal with a Toronto Flying Club member named Frank Trethewey to use part of the Trethewey family estate in Weston as an assembly shed, and waited for the crates. On the 30th of March, 2 moths arrived from England. By the 27th of April, the Toronto Flying Club and a businessman named Lee Shepherd had taken the first 2 flyaway deliveries. The airfield was christened de Lesseps Field, after Count Jacques de Lesseps, who had made the first flight over Toronto from that same ground in 1910. The shed in Weston lasted about 6 months. Demand overwhelmed it before summer was out. In September 1928, DHC selected a 70-acre lot of farmland at the corner of Shepherd Avenue and Dufferin Street in North Toronto, a district called Downsview, and hired the architects Mathers and Haldenby to design a proper hangar and office in brick and steel. The original wooden hangar was rebuilt in sections, with the word Moth painted on its roof in letters large enough to distinguish the de Havilland Airport from 3 other airfields that fronted Dufferin Street: Canadian Air Express, the Toronto Flying Club's second field, and Barker Field, named for the Victoria Cross recipient Billy Barker. It was a crowded piece of sky, but Downsview would outlast them all. Between 1928 and 1939, DHC delivered 439 aircraft across 18 different models from that farmland, including 28 Canadian-built Tiger Moths. By the late 30s, they were the largest civil and military aircraft supplier in Canada. Pre-war employment peaked at 195 people, a cottage operation, a colonial outpost, a seed. What nobody standing on that muddy field in 1928 could have foreseen was that the seed would grow into the most important aerospace company Canada ever produced, or that the farmland at Shepherd and Dufferin would still be building aircraft 94 years later, until the day in June 2022 when the last de Havilland machine was towed out of the hangars and the doors were closed for good. Chapter 2. The Wooden Wonder. The Second World War made Downsview into something its founders never imagined. DHC was designated a crown corporation for the duration, and the Canadian government poured money into the site the way it poured money into every factory that could turn out war material. Fast, without ceremony, and without much concern for what would happen when the shooting stopped. Facility floor space grew from roughly 25,000 square feet to approximately 1.2 million. The workforce swelled from under 200 to nearly 7,000. And that figure doesn't count the 8,000 additional workers engaged across Canadian subcontractors, feeding parts into Downsview. Thousands of those workers were women, Canada's own Rosie the Riveter generation, filling roles vacated by men who'd gone overseas. They built Tiger Moths by the hundred, 1,747 in total, mostly the cold-weather DH-82C variant with its enclosed cockpit, brakes, tailwheel, and heater, because a Canadian training aircraft that couldn't handle a February morning at an RCF base in Saskatchewan was no training aircraft at all. But the signature contribution was the Mosquito. The de Havilland Mosquito, the wooden wonder, built almost entirely of plywood, capable of 425 miles per hour at 30,000 feet, was one of the most versatile combat aircraft of the war. Bomber, night fighter, pathfinder, photo reconnaissance platform. At Downsview, they built 1,134 of them. About 500 were delivered to the United Kingdom by war's end, some flown across the Atlantic by ferry pilots, with several lost on the crossing. The Mosquito was a British design, built with Canadian wood, assembled by Canadian hands, and sent back across the ocean to fight over Europe. The colonial circuit, closed in plywood and glue. When the war ended, the question facing every wartime manufacturer landed on Downsview's doorstep. What now? The 7,000 workers would go home. The government contracts would dry up. The Mosquito was a wartime aircraft with no civilian future. DHC could return to what it had been before, a small assembly operation for British designs, creating moths and tiger moths for a modest Canadian market. Or it could become something else entirely. In September 1946, DHC chose to become something else. It was the most consequential decision in the company's history, and it had everything to do with a country that had no roads where it needed them most. Chapter 3. The Bush Pilot's Specification. The man who changed everything at de Havilland, Canada wasn't an engineer. He was a pilot, and not just any pilot. Clennell Haggerston, Punch. Dickens had earned the Distinguished Flying Cross over the Western Front in 1918, flown the first airmail route into Canada's Northwest Territories in 1929, and spent 2 decades navigating aircraft across a geography that had no equivalent in the industrialized world, the Canadian North. Not the gentle English countryside that Geoffrey de Havilland had flown over, and not the established civil airways of the United States. The North. Glacial lakes with no names on any chart, muskeg that could swallow a float plane to its belly if you misjudged the surface, gravel bars that shifted between seasons, ice that could support a landing in January and drown an aircraft in April. Communities reachable only by water in summer, by ice road in a good winter, and by aircraft year-round. In 1946, DHC hired Dickens as director of sales. His first act was not to sell aeroplanes. It was to ask a question. He polled working bush pilots across the country, the men who flew freight, mail, prospectors, and supplies into the roadless North, and asked them what they actually needed. Not what the engineers at Hatfield thought they should have, not what the British parent company happened to be building, what the Canadian operator, flying in Canadian conditions, into Canadian terrain, required to do the job. The answers were blunt and specific. 1/2 ton of payload. Takeoff and landing from any reasonable lake, gravel bar, or muskeg flat. interchangeable wheels, skis, and floats, because the same aircraft might need all three in a single season. Full-size doors on both sides for loading awkward cargo. All-metal construction, because fabric-covered aircraft rotted in the damp and tore on the bush. Phil Garrett, DHC's general manager, took Dickens's survey and constituted a design team. Wsiłowod Jaki Jakimiuk, a Polish émigré, handled the configuration. Fred Buller was chief design engineer. Dick Hiscox, who had returned from a wartime stint at the National Research Council in Ottawa, and who had spent student summers at de Havilland's Hatfield factory in England, took the wing geometry and aerodynamics. Jim Houston rounded out the core group. The aircraft was originally to take a British de Havilland Gypsy engine. When Pratt & Whitney Canada offered war surplus 450 horsepower Wasp Junior radials at fire sale prices, the design got both a more powerful engine and the original outsized wing. That combination, too much wing for the engine weight by conventional thinking, gave the Beaver its legendary short takeoff and landing performance. Conventional thinking had never tried to get off a lake in northern Manitoba with half a ton of freight and a headwind. The prototype DHC-2 Beaver flew at Downsview on the 16th of August, 1947, with Chief Test Pilot Russ Bannock at the controls. The first production aircraft was delivered to the Ontario Department of Lands and Forests in April 1948. By the time production ended in 1967, approximately 1,657 Beavers had been built. The United States Air Force and Army together took 968 of them, designated the L-20, later U-6A, and flew them through Korea and Vietnam for liaison, freight, casualty evacuation, and search and rescue. In 1987, the Canadian Engineering Centennial Board named the Beaver one of the top 10 Canadian engineering achievements of the 20th century. It shared that list with the St. Lawrence Seaway and the Canadarm, but the Beaver was only the beginning. The same team, Hiscox now promoted to chief engineer in 1949, moved straight to the next aircraft, and the next, and the next. The DHC-3 Otter, the one-ton truck, first flew on the 12th of December, 1951, powered by a 600-horsepower Pratt & Whitney Wasp radial, with George Neal at the controls. 466 were built. The U.S. Army became the largest operator. The DHC-4 Caribou, the company's first twin-engine design, flew on the 30th of July, 1958. A rugged tactical military transport developed for the U.S. Army's battlefield airlift requirement, capable of landing on 1,200-foot jungle strips. The Americans ordered 159 and used them extensively in Vietnam. The DHC-5 Buffalo followed, a stretched, turboprop-powered evolution for tactical military transport that the Canadian Forces flew as the CC-115 for search and rescue through to the late 2010s. Every one of these aircraft was designed at Downsview. Everyone was built at Downsview. Everyone addressed a problem that was, at its root, uniquely Canadian. How do you move people and freight across a landscape that has no roads, no rail, and no flat ground where you need it? The answer that Dickens, Garrett, Buller, and Hiscox developed. Aircraft with enormous wings, powerful engines, fixed undercarriages tough enough to absorb punishment, and the ability to operate from surfaces that would destroy anything else, became known internationally as Canadian STOL. Short takeoff and landing. A discipline that Downsview invented and that the rest of the world's aerospace engineers studied, visited, and tried to replicate. Dick Hiscox would spend the rest of his career formalizing what that design team had done by instinct and field research. He earned honorary doctorates from McMaster, McGill, and Carleton. He received the inaugural McCurdy Award from the Canadian Aeronautics and Space Institute in 1954, an MBE, and the presidency of CASI in 1964. He published nearly 50 papers. He continued consulting until his death in Vancouver on the 13th of December, 1996, and was inducted into Canada's Aviation Hall of Fame in 1998. His monument isn't a plaque. It's every bush plane that ever got off a lake it shouldn't have been able to leave. Chapter 4. The Twin Engine Promise. In January 1964, the design study began for the aircraft that would become the most important thing de Havilland Canada ever built. The goal was deceptively simple: a twin-engine replacement for the single-engine Otter that retained STOL performance while adding the reliability that the bush market demanded and the certification authorities increasingly required for passenger work. One engine could fail, and the aircraft could still fly. That mattered in places where the nearest runway was 200 miles away, and the terrain below was rock, ice, and spruce as far as the horizon. The design was credited primarily to Fred Buller and Dick Hiscox, the same men who had drawn the Beaver, the Otter, the Caribou, and the Buffalo. Bob Fowler would be the test pilot. The enabling technology was the Pratt & Whitney Canada PT6A20 turboprop, 550 shaft horsepower, lightweight, reliable, and available off the shelf from the Pratt & Whitney Canada plant in Longueuil, Quebec. As a proof of concept, DHC had already re-engined a single-engine Otter with two PT6A4s in 1963 and flown it for STOL research. The concept worked. What followed was an exercise in refinement by engineers who had spent 2 decades designing aircraft for the worst operating conditions on Earth. The design features tell you everything about who this aircraft was for. A fixed tricycle undercarriage, no retractable gear to jam, freeze, or fail in the field. Double-slotted trailing edge flaps with ailerons that worked in unison with the flaps, boosting STOL performance to the point where the aircraft could get airborne from a strip shorter than a football pitch. A high-wing cabin seating 19 to 20 passengers, with the wing mounted above the fuselage so that floats, skis, or tundra tires could be fitted underneath without redesigning the airframe. The aircraft could ship from the factory configured for wheels, floats, amphibious floats, skis, or tundra tires. No other aircraft in its class offered that. No other aircraft in its class needed to. The prototype, registration CF-DHCX, made its first flight at Downsview on the 20th of May, 1965. Geoffrey de Havilland himself, the curate's son from Buckinghamshire, who had started the whole thing with a borrowed £1,000 and a crash near Seven Barrows, died exactly 1 year and 1 day later, on the 21st of May, 1965. He never saw what the Twin Otter would become. But the aircraft that carried his name into the most remote places on Earth was already in the air. Production unfolded in 3 series. The Series 100, 115 aircraft with the original PT6A20 engines and a short, blunt nose, ran from 1965 to 1968. The Series 200, another 115, same engines, but with an extended nose for additional baggage and a larger rear cargo door, began in April 1968. Then the Series 300, more powerful PT6A27 engines flat-rated to 620 shaft horsepower, a 450-kilogram increase in maximum takeoff weight, capacity for 20 passengers. The Series 300 would run from 1969 until 1988 and account for 614 airframes. By some distance, the best-selling 19-seat twin turboprop in aviation history. When the last Twin Otter rolled out of Downsview in late 1988, total production stood at 844 aircraft. In 1972, a new one cost about $680,000. By 2018, 3 decades after the production line had closed, used Series 300s were still trading above $2.5 million. There was nothing else like it on the market. There had never been anything else like it on the market. And the reason was simple. Nobody else had built an aircraft for places that didn't exist on most people's maps. Chapter 5. From Downsview to the Ends of the Earth. The list of Twin Otter operators reads like a gazetteer of the world's most difficult geography. Widerøe of Norway was briefly the world's largest Twin Otter operator, racking up over 96,000 cycles a year on short-field routes that the Twin Otter had literally created. Norwegian regional aviation as a system was built around the DHC-6 because the fjords and mountains and scattered coastal communities of western Norway presented a transportation problem that looked, to a remarkable degree, like the Canadian North turned sideways and compressed. The aircraft that Punch Dickens had specified for Muskeg and Glacial Lakes turned out to be the aircraft that Norway needed for Hammerfest and Honningsvåg. Trans-Maldivian Airways put Twin Otters on floats in the Indian Ocean, where the entire national geography is coral atolls, too small for conventional runways, and too far apart for boats to connect efficiently. The saltwater would have eaten a lesser airframe alive. Corrosion in the Maldives is relentless. A daily war against the chemistry of warm seawater on aluminium. The Twin Otter survived it. Aircraft that had been designed for Canadian freshwater lakes turned out to be tough enough for tropical ocean, and Trans-Maldivian built one of the world's largest floatplane fleets entirely around the type. In Nepal, Yeti Airlines flew Twin Otters into Himalayan strips where the runway was a shelf of compacted earth carved into a mountainside. The approach was through a valley with granite walls on 3 sides, and the elevation meant the air was thin enough to cut engine performance by a third. In Papua New Guinea, 60% of an operator's landings were on unimproved gravel strips at high elevation, and the Twin Otter was frequently the only certificated aircraft capable of sustained operations into those communities. In the Caribbean, Winair connected Princess Juliana International on St. Martin to Gustav III Airport on St. Bart's, a runway shorter than most aircraft carrier flight decks, where the approach crossed a public road and the beach was close enough to touch from the cockpit window on final. The Twin Otter handled it routinely, because the same STOL performance that got you off a frozen lake in Yellowknife got you onto a postage stamp in the Antilles. Across Canada and Alaska, the aircraft was everywhere. Air BC, Wardair, Pacific Western, Time Air, Wien. Air Alaska, Quebec Air, Nordair, Norcanair, Transair. The names read like a roll call of a regional airline industry that has itself largely vanished. Ken Borek. Air of Calgary built an entire company around Twin Otter operations in the Canadian Arctic during the oil exploration boom of the 70s and 80s, flying crew changes and survey work into the North Slope of Alaska and the Mackenzie Delta. Then, in 1985, Ken Borek extended that model to the other end of the planet, picking up Antarctic science contracts that would make the Twin Otter famous in places its designers had never imagined it would go. Houston Metro Airlines operated 22 round-trip daily Twin Otter flights from a purpose-built STOL port in Clear Lake City, Texas, near the Johnson Space Center, connecting to Houston Intercontinental in 1976. Rocky Mountain Airways flew scheduled service into Lake County Airport in Leadville, Colorado. Elevation 9,927 feet, the highest airport in the United States ever to host scheduled passenger flights. Shawnee Airlines ran a dedicated STOL port at Walt Disney World's Lake Buena Vista. The Argentine Air Force stationed Twin Otters at Marambio Base in Antarctica beginning in the 70s. The Chilean Air Force put them at Presidente Frei from 1980. Mission Aviation Fellowship, JARS, and Samaritan's Purse flew Twin Otters as missionary and humanitarian aircraft into remote village strips on every inhabited continent, because the same qualities that made it a bush plane, simple hydraulics, cable controls, fixed gear, the ability to land on anything, made it the only aircraft that could sustain operations where there were no mechanics, no parts depots, no paved surfaces, and no second chances. At peak, roughly 115 airlines operated Twin Otters in scheduled passenger service. The aircraft was flying in more than 90 countries. And back at Downsview, the workforce that built them, running at around 5,000 through the late 60s and 70s, making DHC Toronto's largest single industrial employer, arrived for the morning shift at the same gate their wartime predecessors had used, built aircraft by hand in the same hangars, and went home to communities across North Toronto and beyond. Workers carpooled from as far as Newmarket. The Newmarket News would later remember the era directly. I can well remember the early morning departures of the carpooling from Newmarket and area as a child. It seemed to me that half the town worked there. In 1974, as the British parent Hawker Siddeley looked to exit, Pierre Trudeau's Liberal government did something that would look extraordinary by the standards of any decade that followed. It bought de Havilland Canada outright and made it a crown corporation. The rationale was straightforward. DHC was building the Dash 7, an ambitious, 4-engine quiet stall airliner intended for downtown city center airports, and the Dash 8, a more conventional twin-turboprop regional airliner that would first fly in June 1983. The government believed these programs were worth protecting. The price of protection was steep. By 1985, Ottawa had pumped over $700 million into DHC to cover losses and fund development. The Dash 7 had been outflanked in the market by the Dash 8 it had spawned. The company was still bleeding red ink, but in those hangars at Downsview, the Twin Otter line was still running. 844 aircraft and counting. The orders were still coming in. The aircraft that Buller and Hiscox had drawn in 1964 was 20 years old and still the only machine that could do what it did. And then, in September 1984, a new government arrived in Ottawa. Brian Mulroney's Progressive Conservatives won a landslide, carrying 211 seats on a platform that included the most aggressive privatization agenda in Canadian history. 14 Crown corporations would be sold. De Havilland Canada was on the list. The company that Punch Dickens had reimagined, that Hiscox and Buller had made world famous, that $700 million of Canadian taxpayer money had kept alive, was about to be handed to Boeing of Seattle for a fraction of what it had cost to build. And what happened next would determine whether the Twin Otter, the Beaver, and everything Downsview had ever created would survive or disappear. The answer, when it came, arrived from a direction nobody was watching. Chapter 6. The Boeing Deal. The political machinery that would dismantle de Havilland Canada was already turning before the ink was dry on the election results. Brian Mulroney's Progressive Conservatives had swept to power in September 1984 with the largest parliamentary majority in Canadian history, 211 seats, and a mandate that included privatizing Crown corporations the previous Liberal government had accumulated. The apparatus was formalized in 1986 when Barbara McDougall was named Minister of State for Privatization. The federal holding company that controlled DHC, the Canada Development Investment Corporation, which also held Canadair, Teleglobe, and Eldorado Nuclear, was instructed to package the assets for sale. 14 Crown corporations and government-owned businesses would be sold during Mulroney's first term, worth approximately $1.3 billion in total. Air Canada went, Canadair went, Connaught Laboratories went, and de Havilland Canada went. In late 1985, CDIC ran an auction. Boeing of Seattle won. The deal was announced that autumn and closed on the 31st of January, 1986. The published purchase price was 155 million Canadian dollars, structured as approximately 90 million cash and 65 million deferred. Boeing had just acquired an aerospace company that the Canadian government had subsidized to the tune of more than $700 million over the previous decade. The math was brutal, even at the time. Ottawa had spent roughly $4.50 for every dollar it got back. Boeing's stated rationale had two parts, and neither of them was really about building bush planes. Publicly, Boeing said it intended to make significant additional investments in ongoing product development and modernization of the de Havilland plant. They would later claim to have spent more than $400 million upgrading Downsview, and would later sue the Canadian government, alleging they had been misled about the condition of DHC's facilities at the time of purchase. The lawsuit tells you something about the relationship from the start. Boeing bought a company it said it wanted to invest in, then accused the seller of misrepresenting what it had sold. The marriage was adversarial before the honeymoon ended. But the real rationale was the second part, and it was never much of a secret. Boeing was fighting Airbus for a pending Air Canada wide-body order, a contract for what became 34 A330, A340 aircraft, and 34 A320s. Buying DHC put Canadian aerospace jobs on Boeing's side of the ledger. It was leverage. It was a courtship of the Mulroney government, which would have influence over Air Canada's fleet decision. Boeing was buying a Canadian aerospace company not because it wanted to build Canadian aerospace products, but because it wanted the Canadian government to buy American ones. The Mulroney government's official defense of the sale was that Boeing had given guarantees not to discontinue any DHC product line. Twin Otter production would continue. Dash 7 production would continue. The workforce would be protected. Those were the assurances. The company was renamed Boeing of Canada Ltd. In March 1986. Then, de Havilland Canada Ltd. In November 1987, a cosmetic restoration of the old brand, as if a name could substitute for intent. Then, Boeing Canada Technology Ltd. In October 1988. 3 names in 3 years. It was a company that didn't know what it was anymore, because the people who owned it didn't care what it was. They cared what it was worth as a bargaining chip. And in 1988, the bargaining chip lost its value. Chapter 7. The Air Canada Gambit. Air Canada chose Airbus. The decision, for the A320 family, landed in 1988, and it would later become entangled in the Airbus affair, one of the most convoluted political scandals in Canadian history, involving the German-Canadian lobbyist Karl-Heinz Schreiber, allegations of secret commissions, and a defamation lawsuit by Mulroney himself that wouldn't be fully resolved for nearly 2 decades. But that scandal belongs to the politicians. What matters for the workers at Downsview is what happened next. Boeing's strategic rationale for owning de Havilland Canada collapsed in a single procurement announcement. The company had been acquired to win a competition. The competition was lost. And the moment Boeing's political utility for DHC evaporated, the consequences arrived at the factory gate with the efficiency of a corporate decision that has already been made and is merely being communicated downward. In 1988, Boeing announced it would end production of both the DHC-6 Twin Otter and the DHC-7-7 at Downsview. The Twin Otter line had been running since 1965, 844 aircraft, orders still on the books, an operator base spanning more than 90 countries, an aircraft with no direct competitor and no replacement in sight. None of that mattered. The decision was made in Seattle, and it was made on Seattle's logic. The Twin Otter's production volumes were too small to justify Boeing's overhead structure. The margins were thin, and the aircraft didn't fit Boeing's commercial strategy. The fact that the Twin Otter was the most important utility aircraft in the world, that it was flying into places no other certificated machine could reach, that communities across the Canadian Arctic and the developing world depended on it. These were not variables in Boeing's calculation. Boeing built 747s. The Twin Otter was a rounding error. The last Twin Otter built at Downsview was serial number 844. The last -7 followed shortly after. The production lines were dismantled. The jigs, the specialized fixtures and tooling that held each airframe section in position during assembly, without which you cannot build the aircraft, were broken up. Some surviving items were eventually sold off. Much of the tooling was simply destroyed. 23 years of continuous Twin Otter production ended not because the market had dried up, not because a better aircraft had appeared, not because the operators didn't want it, but because a company in Seattle had bought a company in Toronto for political leverage, and the politics hadn't worked out. The workforce at Downsview contracted sharply. Boeing focused what remained on -8 production and subcontract work for its own Seattle airliner programs, fuselage sections, wing components, the kind of piecework that turned a Canadian aerospace company into a parts supplier for an American one. The Canadian auto workers, who represented DHC's manufacturing floor, watched the lines go quiet and the parking lot thin out. The people who'd built Beavers and Otters and Caribous and Twin Otters, the lineage that ran straight back to Punch Dickens and that survey of bush pilots in 1946, were now building subsections of 737s for a company that had promised to protect them. Boeing put DHC up for sale formally in 1989. By 1992, the company had accumulated $636 million in losses on the de Havilland file. In 5 years of ownership, Boeing had managed to lose more money on DHC than the Canadian government had spent in a decade of subsidies. As the trade press summarized with the bluntness that only an industry journal can manage, even with a full order book, DHC was consistently unable to turn a profit under Boeing's stewardship. In June 1991, an offer arrived from a French-Italian consortium, Aerospatiale and Alenia, the joint owners of ATR, the European regional turboprop manufacturer. The deal would have given ATR effective control of the regional turboprop market worldwide. The European Commission blocked it on competition grounds. Then Trade Minister Michael Wilson formally rejected it through Investment Canada, ruling that the consortium's proposed $500 million government R&D commitment over 10 years was an insufficient guarantee of net Canadian benefit. The rejection was correct on competition grounds. But it left DHC in Boeing's unwilling hands for another year, hemorrhaging money and morale. The flag had changed at the factory gate twice in 3 years, Canadian to American, then almost to European, and the aircraft that had defined the company were already gone. The Twin Otter was dead, the Dash 7 was dead, the workforce was gutted, and the next buyer was already circling. Chapter 8. The Long Indifference. In 1992, Boeing finally walked away. The buyer was a joint venture, Bombardier Inc., holding 51%, the Government of Ontario holding 49%. The Ontario Premier at the time was Bob Rae of the NDP, the only Ontario Premier in modern history to use the provincial treasury to take a direct equity stake in an aerospace prime. It was an act of desperation dressed as industrial strategy. Someone had to take DHC off Boeing's hands, and if Bombardier wouldn't do it alone, Ontario would write the check to make the deal possible. Bombardier exercised its option to buy out Ontario in 1997 and folded the remnants of de Havilland Canada fully into its own corporate structure by 1998. The strategy was clear and narrow, the Dash 8. Specifically, the stretched Q series, the Q400, with its Pratt & Whitney PW150 engines, 6-bladed composite quiet propellers, and active noise and vibration control system. The Q stood for quiet, and the Q400 would become Bombardier's regional aircraft signature, and ultimately the most commercially successful Canadian airliner of all time, with over 1,300 built across all Dash 8 variants. But everything else, the Twin Otter, the Beaver, the Otter, the Caribou, the Buffalo, the Dash 7, was dead inventory. Out of production, type certificates gathering dust in a Bombardier filing cabinet, and the global fleet flew on. This is where the story takes a turn that nobody at Boeing, nobody at Bombardier, and nobody in Ottawa anticipated. Because the aircraft that Boeing had killed refused to die. The Twin Otters that had rolled off the Downsview line between 1965 and 1988 were still flying. Not a handful of museum pieces kept aloft by enthusiasts. Hundreds of them. In the Maldives, in Nepal, in Papua New Guinea, in the Canadian Arctic, in Antarctica, across the Caribbean, across Scandinavia. Aircraft that were 20, 25, 30 years old, accumulating tens of thousands of flight cycles in the most punishing environments on Earth. Saltwater, ice, gravel, altitude, temperature extremes that ranged from -65 Fahrenheit at the South Pole to 40 degrees Celsius on a Maldivian lagoon, and they would not stop working. The indestructible reputation wasn't marketing. It was field evidence. In May 1982, Ken Boeing Air's Twin Otter CGKBO broke through the polar ice after landing at the North Pole with a group of tourists. All aboard evacuated safely. The aircraft sank out of sight within 6 hours. The passengers survived because the Twin Otter's high wing and fixed gear had kept the cabin above the ice long enough to get everyone out. In April 2001, Ken Boeing pilots Sean Ludett and Mark Carey flew a ski-equipped Twin Otter from Rothera Research Station on the Antarctic Peninsula to the Amundsen Scott South Pole Station, in perpetual darkness, in temperatures of -65 Fahrenheit, to evacuate Dr. Ronald Chemensky. It was the first winter medical rescue from the South Pole in the 60-year history of the station. A second winter rescue followed in September 2003. In June 2016, a Ken Boeing crew under Captain Wally Dobchuk, First Officer Sebastian Trudell, Maintenance Engineer Michael McRae, flew 2 Twin Otters from Calgary through Chile to Rothera and onto the South Pole, evacuated 2 critically ill researchers, and were honored with a Smithsonian National Air and Space Museum trophy for current achievement. As pilot Sean Ludett had told National Geographic of the earlier rescue, "At those temperatures, steel can break. It becomes almost brittle." The Twin Otter's simple hydraulics, cable controls, and pulleys are what take it through. No fly-by-wire, no digital engine management. Cables and pulleys and a design philosophy that assumed the nearest mechanic was 1,000 miles away, and the nearest spare part was on the other side of the planet. But the operators who kept these aircraft flying through the 90s and into the 2000s faced a problem that was slowly becoming a crisis. Bombardier wasn't making spare parts. There was no economic case for Bombardier to spin up small production runs for a fleet of 800 aircraft scattered across 90 countries when the company's entire strategy was focused on the Q400 and the CRJ regional jet. The parts shortage was acute by the late 90s. Operators were grounding aircraft they would otherwise have kept flying. Some were cannibalizing retired airframes for components. The Twin Otter wasn't dying from any flaw in its design. It was dying from neglect, from the corporate indifference of owners who had never understood what it was or why it mattered. And that neglect created an opening, a very specific opening, for a very specific company on the far side of the country from Downsview. Chapter 9. The Parts Man from Sydney Viking Air was founded in 1970 by Niels Christensen, a Norwegian-born Canadian aviation pioneer, at Victoria International Airport in Sydney, British Columbia. It was a small operation, 25 people doing repair, maintenance, and modification work, specializing in flying boats. The kind of shop where everybody knew everybody, and the founder's personality was the company's culture. In 1983, Christensen secured the contract that changed everything. Viking became the exclusive spare parts manufacturer and distributor for the DHC-2 Beaver and DHC-3 Otter. It was a niche business, modest. The kind of work that kept a small shop on Vancouver Island running without ever threatening to make anyone rich. That same year, through a mutual friend, Hugh Curtis, the former mayor of Saanich and a social credit MLA in the BC legislature, Christensen met Hugh's son. David Curtis was a young forester working in the Queen Charlotte Islands, learning to fly on the Beavers and Twin Otters that were the only way in and out of the remote camps where he spent his days. "I caught the aviation flu," Curtis would later tell BC Business Magazine. He joined Viking. Christensen retired 3 years later and set Curtis up in an ownership role. In 1991, David Curtis became president and CEO of Viking Air. He was running a company of about 60 employees doing roughly $25 to $30 million a year in revenue. A parts shop, a garage, in his own description. And Curtis had an insight that would take 15 years to fully execute, but that he could articulate from the start. For anything in the aviation business to work, you've got to have your own product. You can labor away like a garage, but you'll only get so big. You need your own proprietary product. Through the 90s, Curtis grew Viking steadily on parts and modification contracts for Bombardier, Boeing, and Bell Helicopters Textron. The company remanufactured Beavers into upgraded DHC-2T turbo Beavers, fitting PT-6A34 turboprop engines onto existing airframes. But Curtis was watching the Twin Otter fleet the whole time. He could see what the operators could see. The aircraft wouldn't die. Airframes that were 30 and 35 years old were still flying, still earning revenue, still irreplaceable, and the supply chain that should have been keeping them in the air was broken. In 2003, the patient capital arrived. Westerkirk Capital Inc., the private investment vehicle of Sherry Bridson, granddaughter of newspaper magnate Roy Thomson and the holder of one of the largest individual fortunes in Canada, acquired Viking Air. Brightson's money came with a quality that is vanishingly rare in aerospace: patience. As Curtis put it, it afforded us an opportunity to build the company for the long haul rather than with short-term objectives. In May 2005, Viking purchased from Bombardier the right to manufacture spares and distribute the de Havilland Heritage aircraft product line. And then, on the 24th of February 2006, came the transaction that nobody outside a small circle on Vancouver Island saw coming. Viking Air purchased from Bombardier the type certificates for every out-of-production de Havilland Canada design: the DHC-1 Chipmunk, the DHC-2 Beaver, the DHC-3 Otter, the DHC-4 Caribou, the DHC-5 Buffalo, the DHC-6 Twin Otter, the DHC-7-7, all of them. The transaction price was never publicly disclosed. What it bought was the legal right to build new aircraft, not just spare parts, across the entire DHC heritage range. A 60-employee parts shop on Vancouver Island had just acquired the blueprints to Canada's aerospace heritage. The designs that Punch Dickens had inspired, that Hiscox and Buller had drawn, that 7,000 wartime workers and 5,000 peacetime workers had built at Downsview. All of it now belonged to a company most people in the Canadian aerospace industry had barely heard of. On the 17th of July, 2006, at the Farnborough Air Show in England, the same airshow circuit where Geoffrey de Havilland had first demonstrated the Moth 8 decades earlier, David Curtis announced Viking's intention to offer a new-build Twin Otter, the Series 400. By April 2007, 27 firm orders were in hand, and the project was committed. By November, 40 firm orders and 10 options. A new final assembly hall was established in Calgary. The technology demonstrator, a converted Series 300 with the new avionics suite, first flew at Victoria International on the 1st of October, 2008, and on the 16th of February, 2010, the first new-build production Series 400 Twin Otter lifted off in Calgary. Its serial number was 845. It picked up exactly where Downsview had stopped in 1988. 22 years of silence, and then the line was running again. The Series 400 was the original Twin Otter brought forward to modern standards. More powerful PT6A34 engines at 750 shaft horsepower. A Honeywell Primus Apex glass cockpit suite replacing the old steam gauges. Modernized electrical systems. Composite non-load-bearing structures for weight savings. The same factory configurability. Wheels, floats, amphibious floats, skis, tundra tires. The first delivery went to Zymex Aviation of Switzerland in July 2010. By 2016, 100 Series 400s had been delivered to 34 customers in 29 countries. Total Series 400 production has now reached approximately 150 aircraft. The architectural detail David Curtis was proudest of in Viking's $15 million, 85,000 square foot Sydney headquarters. Brick columns on the exterior. A design frill mimicking the original de Havilland factory at Downsview. The parts man from Sydney hadn't just bought the blueprints. He'd built a monument to the place they came from. Chapter 10. The Last Departure. The acquisitions didn't stop. In 2016, Viking acquired the Canadair CL-215 CL-415 water bomber program from Bombardier, the iconic yellow firefighting aircraft that scoop water from lakes and drop it on forest fires, an aircraft as Canadian as the Twin Otter in its own way. In November 2018, Viking's parent company, Longview Aviation Capital, Sherry Brideson's holding company, announced the acquisition of the entire Dash 8 program and the de Havilland Canada brand name from Bombardier for approximately $300 million. 1,200 Bombardier staff transferred to a newly constituted de Havilland Aircraft of Canada Limited, headquartered at Downsview. For the first time since Boeing had dismantled the production lines in 1988, every original DHC-type certificate, and now the Dash 8 too, was under one Canadian roof. Curtis on the Dash 8 negotiations. We were living in a boardroom in Montreal eating pizza for a couple of months. The company that had started as a 25-person flying boat shop in Sydney now employed roughly 1,700 people across British Columbia, Alberta, and Ontario. Revenue had climbed to approximately $1.5 billion. David Curtis, forester, floatplane passenger, parts man, CEO, had built an aerospace company from a garage and a set of blueprints that the corporate giants had thrown away. He retired as executive chairman of Longview Aviation Capital on the 1st of August, 2021. He'd done what he set out to do, but Downsview was dying anyway. The resurrection in Victoria and Calgary could not save the place where it all began. Bombardier had sold the Downsview property to the Public Sector Pension Investment Board for approximately $635 million in 2018, with a leaseback arrangement. Longview inherited the lease when it bought the Dash 8 program, but the expiry was hard and the economics were clear. You don't run an aircraft factory on land that a pension fund values at over $600 million. On the 17th of February, 2021, in the depths of the pandemic, de Havilland Canada announced a pause in Dash 8 production at Downsview and approximately 500 layoffs. Unifor Local 112, the successor to the CAW Local that had represented DHC workers for decades, demanded a federal bailout. In July 2021, The union threatened a strike over the Dash 8 program's planned relocation away from Downsview. The strike did not save the factory. Nothing was going to save the factory. On the 11th of June 2022, de Havilland, Canada held a private ceremony. 94 years of aviation manufacturing at Downsview, commemorated in a single afternoon. 10 DHC types were arrayed in the hangars, from a 1942 Tiger Moth to a 2019 Dash 8-400. The people who attended were the people who had been there: engineers, line workers, managers, retirees. The doors closed afterward. The DHC offices moved to Mississauga. On the 23rd of March, 2024, the last aircraft ever to leave Downsview, a Bombardier Global 7500 business jet, registration CG1, serial number 70193, took off for Montreal. Bombardier confirmed it was the last departure from the airfield. The runway that had been in continuous use since 1929 fell silent. The 370-acre site is now being redeveloped by Northcrest Developments as a $30 billion residential district called YZD, named for the old airport code. 7 new neighborhoods, more than 50,000 residents. The runway will be preserved as a 2.1-kilometer pedestrian park. Centennial College has reused the original 1929 de Havilland Plant No. 1, the brick and steel hangar that Mathers and Haldenby designed when Bob Loader's Weston shed ran out of room, as a teaching facility for aerospace technicians. The building that housed Canada's first aircraft factory now trains the next generation to work somewhere else. De Havilland's manufacturing future lies 1,000 kilometers west, at a greenfield site called de Havilland Field in Wheatland County, Alberta. Twin Otter, Dash 8, and DHC 515 firefighter production are planned for consolidation there. First production was originally promised for 2025. The most recent reporting puts the Dash 8 restart at 2033, 8 years behind the original timeline. The Phoenix rose. Whether it has fully landed remains to be seen. Chapter 11. What the wind carries. Of the 844 Twin Otters built at Downsview between 1965 and 1988, somewhere between 220 and 315 remain in active service worldwide. 6 decades after the first prototype lifted off that Toronto farmland. Add Viking's 150 Series 400s, and the total active fleet is in the order of 400 aircraft, flying in more than 27 countries. The British Antarctic Survey's 4 ski-equipped Twin Otters still log approximately 1,300 flight hours per Antarctic season from Rothera Research Station. Trans-Maldivian Airways still operates one of the world's largest floatplane fleets on the type. Yeti Airlines still flies into Himalayan strips where the approach is through granite valleys and the air is too thin for anything else. Air Tindi, Air Inuit, Ken Borek, Aklak Air. They still serve First Nations and Inuit communities that have no roads, no rail, and no other way home. The newest variant, the Twin Otter Classic 300G, announced in 2022, puts Garmin avionics into the original Series 300 configuration at a list price of approximately $7.25 million. The only out-of-production airliner ever successfully relaunched. There is no second example in aviation history. The ownership arc is written on the factory gate at every transition. British, from 1928 to 1959. British conglomerate under Hawker Siddeley, from 1960 to 1974. Canadian Crown Corporation under Trudeau, from 1974 to 1986. American under Boeing, from 1986 to 1992. Canadian again under Bombardier in Ontario, from 1992 to 2018. Canadian once more under Longview, in a revived name, from 2019 to the present. The flag changed 6 times. The aircraft kept flying. Downsview is quiet now. The hangars where 7,000 wartime workers built mosquitoes from Canadian plywood, where Punch Dickens's Bush Pilot Survey became the Beaver, where Hiscox and Buller drew the Twin Otter on drafting tables 40 feet from the production floor. Those hangars are being measured for condominiums. The runway where Russ Bannock first lifted the Beaver off the ground in August 1947 will become a walking path. Children will ride bicycles along the center line where 844 Twin Otters began their first taxi. But the aircraft are still out there, on a glacier in Antarctica, where Ken Borek's pilots nurse the engines to life at temperatures that make steel brittle. On a lagoon in the Maldives, where the salt air that eats lesser machines is just Tuesday. On a gravel strip in Papua New Guinea, where the runway ends at a cliff face and the margin for error is the length of a cricket pitch. On a frozen lake in the Northwest Territories, where a community of 400 people gets its mail, its medicine, and its fresh food from the cargo door of a 60-year-old aeroplane that a man in Buckinghamshire started building when he borrowed 1,000 pounds from his grandfather and crashed in a field in Hampshire. The wind comes in off the harbor at Sydney, British Columbia, where David Curtis built his company from a parts catalog and a conviction that the blueprints were worth more than the corporations that had abandoned them. The wind comes in off the Atlantic at Downsview, where it carries nothing now. Not the sound of engines being tested, not the whistle that called 3 shifts to work, not the vibration of a factory floor that shook for 94 years and then stopped. Just the wind, just the runway, just the quiet. And somewhere, 1,000 miles north or 10,000 miles south, the sound of 2 Pratt & Whitney turboprops at takeoff power, carrying passengers to a place no road has ever reached, in an aircraft that Canada built, that America discarded, and that a parts man on Vancouver Island brought back from the dead.